Okay, welcome to Cloud Data Driven Online User Group Meeting. Who am I? I am Jean-Joseph, currently working as a data engineer. I've been in IT for over 18 years, and I'm located in New Jersey, originally from Haiti, and I'm your host for today. The rules are you guys are free to comment with respect. There must be no offensive comment. I have your microphone turned off, but I would highly suggest you to keep your video off. If you guys have any questions, raise your hand and I will unmute you. Or if the speaker wants you to ask question, I will be happy to unmute everyone. Let's get connected together. Follow us on social media at Cloud Data Driven, and also on LinkedIn, Facebook, Eventbrite, YouTube, Meetup, and Twitter. Our presentation for 2 days is transitioning your T-SQL scale to SQL Spark. That's a great session. And the speaker is John Miner, by the way. Thank you so much, John Miner, for your presentation. And it
My
is an
pleasure.
honor to have you here. John Miner is a data architect at Insight Digital Innovation, right? He's helping corporations solve their business needs with various data platform solution. We have a tons of presentation lined up, and also we have Haitian data driven coming up this Saturday, and John Miner is part of it as well. I would highly suggest you to register for that. There are tons of great sessions and a lot of great speakers. You guys are free to reserve your spot. On April 1st, we have a Deepti that will present for us a method behind the magic of indexing SQL Server. That's one of their great presentations. I would highly suggest you guys to, save your spot for this presentation, even the one on optimizing SQL Server for large table scan. Both of them related to performance tuning. I would highly suggest you guys to, be with us and also learn from others how we can maintain our environment. If you guys want to present any session, I can be reached at jean.joseph@bigdatadriven.org. Please email me and submit your session. Right now, John Miner, the floor is all yours. You are free to share your screen, introduce yourself, and start with the presentation.
Hey, thank you, Gene.
You are welcome.
Appreciate it very much. If I cough a little, again, it's my allergies this time of year, so I apologize in advance. A little about myself. I'm going to share my desktop, and you should see it right now, and I'm going to bring up Chrome. So we're going to start with Twitter. So if you want to reach me, I'm the Crafty DBA. I have a website called the Crafty DBA. You can go look at it. Has some old stuff. I just said, hey, live long and prosper, because we're going to be talking about what? Spark. I've been talking for a long time. So if you go into John Miner 3 at GitHub, you can download today's presentation and all the code samples. Okay. This video is being taped, and I assume Gene is going to be putting it on YouTube. And so you should be able to see the video out there. So it's transitioning T-SQL skills out to Spark. Click there. There's the code samples we're going to talk about today. They're in two different forms, a IPython notebook, so this is Jupyter Notebooks, and there's also the code, as well as a Databricks dump, okay? It's a catalog. I've been an MVP for 5 years, and probably be obtaining the award again this 6th year. I've been in the industry for, wow, probably 30, 31 years. So time does fly. If you're curious about what I've done in the past, take a look at this. Also, take a look at my LinkedIn page because I do keep updates where I'm presenting each month there, so you'll see updates. I am an avid writer at msqltips.com. So if you take a look at this, I have a ton of tips. One tip I do want to point you to after this is there's a tip called Azure Databricks Local File Management. And it gives a little twist on what I'm talking about today. It's more focused just on file management. Today, we're going to talk about a little everything. Okay. If you're not familiar with Azure Cloud, this is the Azure Cloud, and this is the Cloud Data Driven User Group, Databricks. And so I have a workspace here. Okay, so it's an Azure object. This is a service. Okay, and there's two resource groups. The first resource group is where the service is deployed. But if you use PowerShell, you can also put the managed by Databricks because it's its own system resource group in another one. We'll talk about how clusters spin up and spin down VMs. Okay. Other things you might want to use in the future, and again, this is just a sample here, is a storage count. Of course, we want, data lake storage, a key vault, Databricks. This is a database. Maybe we want to surf up, maybe a little ODS, an operational data store at the very end. But we're going to talk about that later. So that's enough about me. I did see, whoops, not this one. Someone's talking to me. So let's close. Wish I could close Teams, but I am talking in Teams. So I'm just going to ignore that window. It's people at work talking to me. So let's get into the presentation, and then we'll eventually go back to the demo. It's a hands-on demo, so it should be pretty good. So again, my name's John Miner. I'm a data architect at Insight Digital Innovations. Today's talk is about transitioning your T-SQL skills to Spark. And what do I mean by Spark? There's two ways to do Spark. You can do data frames, okay, if you're using Python, and most people are using Python, or you can do Spark SQL, and we're going to talk about both of those. Again, like I said, I'm an MVP, Microsoft certified in SQL Server, as well as data science. I wish I had time to do more data science, but I'm doing the plumbing most of the time for most companies, okay? And I do see, I'm going to escape out of here for a second, and I'm going to make my video go just a little faster if I can turn, oops, this off so you don't need to see me. There we go. So we can go a little faster by doing that. And I'm going to present again here. And then I'm going to go to the right. My mouse doesn't want to work right now. There we go. Okay. So many companies, like I said, I present a view. So there we go. Many companies were moving to their many companies, again, like I've been working for digital innovations for 3.5 years, so I'm just gonna step back for a second. And what I've been doing for the last 3.5 years is enabling companies to move workloads to on-premise to the cloud, okay? In the past, a lot of people did something called an operation data store, and that was just like maybe SQL Server, Teradata, if you could do an MPP, or APS, which is Microsoft's appliance, right? That would be on premise, right? Divide and conquer, okay? Uh, you know, lately, okay, since Databricks has come out basically in 2018, and Microsoft invested a lot of money in that company, uh, Spark processing platform has been a key player in this transition. Okay, nice thing about Spark, it allows you to do divide and conquer. Okay, and it allows you not only to work with the data, but you can also do ML and some type of analytics. Okay, and we'll talk all about that. So what we want to do as a developer is to learn how to leverage your existing SQL skills and take advantage of this growing segment of work. Because, like I said, the last 18 months, I've been doing a lot of Databricks, okay? And so if you know the basics of Databricks, you can start your first project. And if you're like me and you've done it for 18 months, you've probably seen a lot and you're pretty good at it. And having this growing segment of work will keep you very marketable in today's world, okay? So I'm going to talk about the concepts and the code to help you during this transition, okay? So topics, what is Spark, right? And what is a data lake, okay? How do we work with files and folders? Because, a data lake is just basically a storage device, right? How can we read and write data? We're going to talk about the Hive catalog, right? And then we're going to review some SQL constructs, okay? Then we're going to review Spark SQL functions, and we're going to show you a couple known differences. I can spend a whole hour talking about Spark SQL functions. There's so many of them. We just don't have time, but I'm going to show you how to do some complex ones, like maybe a CTE, maybe some windowing functions, and show you that things that you can do in SQL, you can easily do in Spark. Okay. So at its core, this is Apache Spark, and I'm just circling this right here with my mouse, okay? But at its core, it's a unified processing engine, okay? And it's for big data, right? So it works by taking data and dividing it equally and a bunch of nodes, okay? So you have a driver node and you have a worker node, right? And each worker node has slots, and so you can give data to each slots. And the idea is to divide and conquer it, right? So we're going to take the data and divide it and conquer it by processing it. Now we see there's four different, um, you know, spokes coming out from the centers, okay? From the hub, Apache's the hub. The spokes, we have SQL and data frames, okay? There's also something called data sets. So let's talk about the differences. Spark has been a growing language since the beginning of this last decade. So I forget exactly what year it came out. It was maybe 2012, somewhere around there. It was a research project and for a grad student, and it's been built by the community. The thing is, there's many different languages that you can use with it. At its core, it's based on Scala, okay? And Scala is just basically an object version oriented version of Java. So when we talk about data sets, we're talking about a data frame that's tightly bound to some type of data, okay? A data frame, on the other hand, is a schema on reads. So basically, you can say, hey, infer to schema, don't infer to schema. And SQL allows you to do transformations, such as like in a data frame, maybe you join two data frames. In SQL, you can join two tables, okay? So we're going to, most of our focus is going to be right in this one box that I'm circling. But there are other boxes to know about. There's a graph engine, okay? So if you were trying to solve the traveling salesperson, like, hey, I'm going from Chicago to Providence, Rhode Island, that's where I live. And maybe there's different ways to go. I could go through Albany, New York. That's one place I've talked to before. I've been close to Pittsburgh recently because I picked up a dog with a friend in Kentucky. So maybe it's two ways. So what's one's going to cost me the least money, less tolls? Maybe there's another one you might say, hey, what's the quickest way to get home, right? So that's a graph problem, and that's how the graph engine could be used, okay? What is streaming? Today, we get data not only from the database, but we get data, okay, coming in really fast from these devices, okay? And when the data comes in from devices, right, it might go to Event Hub. Event Hub just captured these. How can we consume that data? That's streaming, okay? And we're not going to talk about that today, but that might be an entrancing topic to talk about in the future. Last but not least, machine learning. Machine learning is based upon some of the toolkits that came out of MIT, scikit-learn and so on. And it's geared towards using a divide and conquer versus, when you do it, usually on one machine, you can only scale up. You can't scale out, okay? And what I mean by scale up is if I used a DSVM, I could add more compute, I could add more CPU to it, more memory, and I can read bigger data sets, right? For Spark, it's scale out. Guess what? I have n nodes and I have to divide it in stages. And if I have a limited number of stages, it just takes longer to run. But if I want to go fast, I just give it more nodes, which are more computers, and it runs faster. So let's review what I just talked about, the cluster. Each cluster has a single driver, okay? That is the control node, okay? And each control node, okay, has executors, okay? Now, there is many different clusters you can set up. You can set up a standalone cluster, and that means the driver and executor on the same node, and then it's just threads that are actually doing this. Or you can do a standard cluster. Okay, a standard cluster actually has this diagram. We can also use a high concurrency cluster, and that means we're doing AD pass-through, okay, to the data lake, and it's the same diagram here. So again, when you break up a job, the task is given to the slots on an executor, okay? And that's how we do parallel execution. And basically, all the magic is in a driver, how to partition data and actually do the processing. What is the optimizer? Well, Spark is just like SQL Server. It has to take something that's logically written in code and figure out a physical plan to pull in data from disk, put it in memory, how to process it in memory, and then put it back to disk if you're writing back. I want to step back one thing and just mention something I forgot here. See this right here? Spark is not only written in Scala, but it's executed on Java virtual machines, right? So at the base, Scala is the next level above Java, and we can see it runs on a virtual machine. So that means that anything that we do with a data frame, anything we do with SQL, eventually has to be translated to Java bytecode, okay? So this whole image here is called the Catalyst Optimizer, okay? And this basically takes a notebook, okay? And what it does is it converts the notebook in from either SQL, the data frame. We talked about data sets that are tied to Java / Scala only. Data frames could be like R, could be Python. It creates a plan. It might be pulling from the Hive catalog as a table. So you're going to pull this. You're going to come up with this logical plan, and then you're going to try to optimize it. And then this optimize might come up with several different plans. And we're going to use a costing model just like SQL Server and pick a final plan. In reality, when it creates the plan and executes it, how does it work? It uses something called a RDD, which is a resilient distributed data set. What is a resilient distributed data set? Well, it's an immutable object in memory. So if I read something from disk, I get object 1. If I take the actual quantity times the cost for, say, let's talk about the VentureWorks database. We got bytes, right? So we got a row that has the quantity, a row that has the cost, right? 2 columns. We multiply them, right? We get the sale for that line item, right? But does that get back into object 1? No, we have to create another object because the previous object is immutable. Okay, it's in memory. Okay. And Optimizer is the big difference between the open source Spark and Databricks environment. Databricks has worked with Microsoft and internally themselves to optimize this code. So before we get into anything, I have to show you kind of a tour of what a Databricks is, right? So we got workspaces, we get clusters. How do you import a file? What is a Hive database, right? What are notebooks? What are jobs, right? So we'll get into that right now and quickly go to switch screens. So again, I said I deployed it this way. You don't have to deploy it this way, but this is my this is a Databricks environment. So when you go to Databricks and you click on the object, say on your desktop, maybe I pinned it like I did, it's going to come up and everything is called a workspace. So you launched a workspace, okay? And once you launched a workspace, you come into this interface, okay? And so we can say, hey, new notebook, new cluster, new job. We can do experimental ML flow, so on. So there's a lot of things we can do. It also shows you common files. So we're going to be talking about these 4 notebooks, okay? They're all in Python notebooks, okay? And so this is the launch place. It's the home page, right? We can also look in here in the workspace, okay? And in the workspace, we can search. Now, there's 2 things we have. We have, okay, users, and we have a shared workspace. So in the shared workspace today, if we drill in, we can see that I wrote that DBFS article for MS SQL tips. That's there. I also have a Delta Lake article sitting there ready to go. And I had this talk. And so we can organize by folders and subfolders inside the workspaces, okay? And if I click this, it's going to bring the program up. And there's interesting parts of the program. It has a markdown language. I hope this didn't shut down. Maybe it did. No, it's just thinking for some reason. And I've noticed for some reason my markdowns have not been running lately. So do not know why. So let's do this. There we go. So now it finally showed up. So I got this little image that's pulling off the system. Okay, it's on a local file system. And we can do a markdown. If we double click it, it's just like HTML. We have, an avatar. That's my little crafty DBA avatar. And basically, I'm talking about all the steps that I did in this notebook. So I listed out the algorithm, and in each one, I can go ahead and show you how I did it, okay? So that's our workspace. We talked about recents. What's data? This is your Hive database, okay? So this will not load unless a cluster is running. So I already started cluster, so we can see that there's a New York City, okay? And there's basically a bunch of tables. I also loaded the AdventureWorks database. So if we look in here, we can see that there's a dimension here. And if we were interested, we could click on this. and it's going to bring up a sample of the data and tell us what type of data it is, okay? So we can see this is a schema, and it's a delta table, and we'll basically get some data. We'll talk about delta tables shortly, but maybe I'll jump into it while I'm waiting for the sample data to come up. Basically, delta tables are the next version of a parquet table, and they allow you to do ACID properties, and it's really cool, and we'll get into that shortly. Last but not least, we talked about clusters. So when you do a cluster, you can specify how big you want and how long it stays alive, okay? These are two interesting sentences. First one is you might want to make sure this is checked off. Unless you want to spend extra money, if this is not checked off, then the cluster is not going to go to sleep when you're done. Also, if you have to, when you edit it, you have to actually stop the cluster to make the changes, right? And so at this point, if I edit it, I could, for instance, there's no pool, but I could go ahead into, does it allow me standard, but it doesn't allow me to change the type once you do it. So I'd have to do like, you know, clusters, and then I have to create cluster, and then I can show you the types. So again, there's three types. The first type is standalone, which is single node. And that means you don't get to specify how many you know, node types you have. You just have one node type, right? So I have 4 cores and 14 gigs to do all my processing. That includes the you know, the driver as well as any worker nodes, probably 1 worker node, right? That's not you really divide and conquer, right? Standard, we get to specify how many worker nodes. So if I always want to use 8 worker nodes, then great. Problem is I'm going to spin up 8 worker nodes, but the optimizer might choose to create a plan that doesn't use all 8. So at that point, you're just wasting resources. So you can also size not only the number of nodes, but you can specify the size. So for instance, we have a DS3. Maybe I wanted to have something that had 16 cores and 56 gigs. So now we have a lot more slots per each node, right? Again, make sure you turn this to say 15 minutes or 60 minutes so you don't get charged, okay, for stuff that you don't use. Okay, so that's how you do clusters. Pools are an interesting thing. Pools allow you to carve a cluster out of some resources that may or may be available, okay? So if we kick off a job and we define the cluster out of a pool, what happens is the first time when we need resources, it spins up resources in the pool. And then after you spin up the resource in a pool, this one says min idle is 0, max idle is 18. So that means I can go down to 0 nodes, but up to 18. So that's 2 times, you know, a header node, which would be 1, say 8 worker nodes. That's 9 nodes per cluster. I can have 2 clusters running up to 8 nodes, right? Worker nodes. So that's cool. And it would carve it out of this actual space. Nice thing about this is that every time you spin up a cluster, okay, there is a hit, okay, that's occurred for spinning up the cluster. So we want to keep the resources active and alive as long as possible before we stop our job. And this is how it allows you to do that, is by carving out of clusters. Job clusters is when you don't have an interactive cluster. And right now we're using interactive cluster to do queries, okay? I'm not going to go into models, but jobs, you can just right click, and if you have some code, you can tell it run the code and schedule the time and tell it what type of cluster to run it under, okay? So I think I did a really good overview of the Databricks service, but we still have some more concepts to go over before we can actually start doing some work. Okay, data lake zones and data quality. Okay, so we talked about having data either as batch, so we're copying from some source system, to the bronze or raw zone, and we can also stream and do it to the raw zone. Because the raw zone or the bronze zone is the first place in the data lake for quality, okay, we're inserting into it, okay? More than likely, we're not doing updates here. I usually use the silver zone, okay, to have a delta table. Reason why I choose a delta table, it's almost like SQL, okay? I can do a upsert, I can do a delete. So all your CRUDs are available. You can select from it, you can insert, update, and delete. Last but not least, usually the gold zone, and again, this is raw, refined, curated, one way to say it, or some people say bronze, silver, gold. So this is my curation. I might take, say, for instance, the VentureWorks database and do some type of aggregation. And that final aggregation I'll leave here. And Power BI allows you to talk right to the cluster. You could do it that way, or you could save it back out as a Parquet file, and then Power BI can read it right off ADOS. So the choice is yours. It depends on how you want to architecture. Okay, so data dictionary. One of the things I suggest to use with a data lake is a data dictionary. The client I'm working with, we built a framework. Every time we write something to the framework, we tell the location, the file name, and also the file type and the number of records stored in the file. It is very important to use standard name conventions, especially on directories, folders, and so on. So the company I'm working with has an EMR system. So what is it called? Medical record system. So enterprise medical record system. So EMR. And so for instance, in our directory, we would have RAW, so that's your RAW directory. And then after that, you might have Epic, which is the client who, the company that builds the EMR. And then we're pulling it from the reporting database, which is Clarity / and then we might do /DBO and then file names, right? And then on the file name, we might do /folder. And the folder might actually have today's date and month. So for instance, to have it be sortable in the right direction, right? We could do 2021-03. And then underneath there would be the data file name again, and maybe a date timestamp and then .parquet, okay? So various file types. There's two types of file types that you can work with. You can do either use weak file types or strong file types, okay? Weak file types are like comma separated values, Java, JSON, right? Both of those are text-based. They bloat real easy, so if you want to fill up your disk, go for it. Also, they don't allow for compression and can be easily broken. So if I go into any of these files with a text editor, I can easily edit them. Anyone that has access to the directory can easily look at the data. So it's, no type of hiding the data from the users, okay? Strong file types are more like Apache file, Parquet format, okay? The data stored as binary. One of the things I like about is that you don't have to guess at the column names, right? Because CSV, yes, you have to have a header line. If you don't, then you have to put in the column names, right? As for types, guess what? You don't have to guess too. So the problem with CSV is that most systems have to read up the CSV file before figuring out the type, unless you pass a schema. Okay, and we'll talk about passing schema in the future. And also, it allows for compression. One thing is wrong with JSON is that, I keep on saying JSON, but it's JSON documents, right? Is that JSON documents basically might lose precision, right? So if you have a floating point and you have to convert it to a text, there might be some rounding. It'll be minuscule, or should I say minute rounding that's going on. But the problem with the very small rounding errors is that if you want something really um, to end decimal places to the right of the decimal, you might have to shorten that because of rounding, okay? So we talked about data dictionary, we talked about various types. Okay, load patterns. So there's several different load patterns, right? We can do a full load. Full load's the easiest, right? Problem is it doesn't work really well to medium to large data sets. So if I have to copy over a large data set, and then in my example, I have the New York City database, right? And I'm going to show you that we have to reload the data from gzip Parquet files because there's one field that didn't get fixed. So we're going to fix it, but the problem is if I did it in real time, it'll probably take 10 or 15 minutes to copy all the files over and read them up and do what I need to do for processing, right? However, okay, that would not be a good thing if the clients were waiting to get the data from that table, right? They were querying it. So again, a full load pattern is really good for small data sets, or sometimes you have to do it to seed a large data set. And usually on the full load, you'd break it up and it would be basically looking like an incremental load, right? You would say between a where clause, between these two watermarks, go ahead and load the data, right? The incremental, okay, usually starts with a full, like I said, but then you get an update file, right? And again, this can be small to medium, really good. Problem is when it becomes large, right? Then how do you handle maybe a rolling window? So partitioning really helps, right? Also, larger get, the data time for retrieval increases, right? So if we always look for I don't know, patient ID, and if we order by blocks of patients' IDs, then guess what? Using a hash function, then we would probably get to data faster versus if we don't partition. So like I said, I like Delta files. The Delta file format actually came out in 2000, I think 18 December, maybe 2019. So relatively new. It was by Databricks that came up with it. Nice thing about it is based upon Apache Parquet files, it allows ACID. So it means you have atomic, consistent, independent, and durable transactions. You can enforce schema. It also allows something called time travel. So you mock a point in the delta table, and each time you append, say upsert, and then you could say, hey, go back to yesterday. What did the data look before I did the data load? And you can actually pull that view out of the table and look at it, which is great. Also, snapshot isolation. The problem with a Parquet file, say if we used as Parquet as the final one, we want to update it, well, we would first have to read the Parquet file and say we're going to add 3 records. We pull in a data set, right? A data frame with the 3 records. We merge the 2 data frames, but then we have to write it back out, right? So we can see that's very inefficient versus just saying, hey, insert 3 records. It's also open source, so Databricks gave it to the open world. Let's talk about the Databricks file system. And again, I'm going to get into examples pretty soon for this first one, but I got a few more things to talk to about. One is that there's 2 types of file systems for Databricks. One is local and one's remote. So local means, and again, this is in the cloud, so everything's remote, but it means the data is closer, okay, to the compute than something that is like Azure Data Lake storage. So the remote storage can be either mounted or attached to at runtime. So if you give the credentials in the Spark session, then you can do it at runtime or you can mount it. I'm not going to talk how to do that, but I just wanted to talk about the different ways, okay, to actually work with the file system. So we can do %fs, that means run a file system command. ls/temp means show me what's in temp, okay? That is just basically using a magic command. Anything with % in front of it's a magic command, like %SQL means run a SQL statement. So I could have a Python notebook, but still run Spark SQL in it. I could do %Scala if I wanted to mix languages, which I try to avoid, especially if you want to do a high concurrency, only support SQL and Python. Last but not least, you have these other ways to do it. You can do %sh, that means shell command. %bash means run a bash command, okay? But one thing I want to note is some of these commands are different, right? The dbutils fsls is something for either, Python or, Scala, but this is saying, hey, go ahead and use this library, same thing. We noticed that this root, okay, which is the hot Spark connection, okay, the hotspot, is not appended to this, okay? So you don't have to append it for these 2 commands. However, if we're importing using, say, Python directly, not a utility that's written for Spark, which is distributed, then guess what? We have to go ahead and use a OS, which is OS list directory, but then we have to append it. Same thing with this one. So just make sure when you use the right command, you use the right prefix, okay? PySpark. Let's get into our first example. We'll start doing some work, okay? PySpark. Read and write files. PySpark is a Python API for Spark to process large data sets, so it knows how to pick it up and distribute it. It's written in Spark and does all the fun stuff we talked about. There's 2 main things you need to know about when you start, working as a big data person for Databricks. One is Spark.read, Spark.write. I just want to say it's not per se just Databricks. If you were also doing work with Synapse, then anything in these same constructs are applicable, okay? So let's go to our cluster again, and we're going to go back to our workbooks, and I'm going to bring up the very first workbook. And hopefully my cluster did not go asleep. If it did, then I will go on to something else while it starts. And it's thinking. So the main thing is this is an interactive cluster, and to do anything in Databricks, you have to have something to do compute against, right? They did some really cool things. This was just run cell before. They did a new thing, which I really like. You can say, hey, run above. And so let's run commands above, and it says, hey, run this, and it brings my crafty DBA, okay? So the first thing is I want to show you is there's a ton of sample data sets, okay, out there, okay? So if we do file, run cell, okay, this is going to list all the Databricks data sets. Now, this is using, okay, and again, it's waiting to get the compute to run, okay. This is using the file system command, and it will give you kind of a grid. And sometimes when you get a grid, you can actually plot things. So for instance, if I want to do a pie chart, it doesn't really make sense. It's kind of weird, right? We can't plot it really. Bar, we could do bar, but maybe it's just saying, hey, PySpark area. Or we can just go back to grids. So the nice thing about it is when you run commands, not only you can get data, but you can actually look at it right there using this little charting tool, okay? That's your quick analysis. Last time we did %s, right? So that is fs, that's our file system. This is the shell command, sh, okay? But it has to use, the prefix because dbfs, Databricks file system, has to be prefixed. Now, when we run this cell, okay, we get the same results. The only thing is our output's different. Instead of now having some type of object that's returned, okay, we're now having just text returned, okay? Let's look at the power plant dataset, right? So the power plant dataset is underneath the Databricks dataset power plant data, and it has these TSV files, okay? So if we ran this, it'll run those. I'm not going to run each one of these because we don't have enough time. The interesting thing is we could, go ahead and cat, which means cataloged, right? The output, and we can look at the TSV1, and it's a tab separated value worksheet, and we can see there's different columns, right? But we don't know what the columns are. A lot of times when these data sets are presented, if we look hard enough on the file system, we might see a README, right? This is this is a Python program. And again, I'm having to prefix it with the path dbfs. And what I'm doing is bringing the README file in, joining all the lines and printing it. So if we go through this, we can see some information about, hey, where did this come from? Well, it came from uci.edu, okay? And it's a machine learning repository for a power plant. So we can see sensors, gas-fired power plant, okay? And then also, what I did is I went to this website, which is somewhere in this article right here, and looked for it, and I pulled this out. So if we're curious, right, we can see T, which probably responds to AT, if I remember right. Okay, that's our temperature, right? And then we had V, right? And V is exhaust and so on. So we now have a description of how the data is broken down to columns. Let's actually do something with it. So our very first thing is we can actually go ahead and read it up. So if we do file and run cell, okay, this is going to first, we don't need it because it's a Spark command. We just need to give it to the path. We don't need to prefix it with dbfs. And there's a bunch of options for the read. We can format it. We can tell it's a header. We can tell it's delimited. We can say, hey, use a double quotes, to nothing. We can also say infer schema. So if I wanted to pass a schema, we could. We don't have to. I'm going to load it into memory, and I'm going to repartition it. I'm going to display it, okay? So once we have the data, now we can actually do some charting. So for instance, if we did a line chart, okay, and let's say we go to plot options, now we can say, I don't know why these don't do it. We don't want sum. We just want average. Nah. Boom. Boom. Keys. Why doesn't it? And then bring it down here. Does that work? There we go. So if we plot the data, it was making some mess. I don't know why it's asking me to run it again. But it actually now plots V over temperature versus pressure, right? And we can see at different temperatures is different pressures, right? And we see there's a spike. So we did do some analysis, and if I was an engineer, then I could probably explain why there was a spike in, say, pressure at a certain temperature, okay? Let's go back to the Spark execution. I clicked it, but I didn't really tell you what's going on. There's a couple things. One is when you actually read a data frame, and it's going to give it, even though I inferred schema, it's going to give it a structure, okay? So this is the struct. Double, 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 so on, right? Second thing is the job. When the jobs actually run, okay, it breaks into stages. Remember I said how you're going to run the jobs, right? And so now what we can do is we can actually click view. And again, this is where it becomes, this is a more advanced topic. I just want to gloss over it really quickly. We only have about 20 minutes left. But we can see we're going to do a scan text and a whole stage gen. And we can see that, you know, it came off a pull, right? There's nothing there going on. So then we can go to the next one and take a look. So scan CSV, so it's running a CSV. And then there's no output, right? But shuffle right. And then let's see if I can find something that's interesting. So now scan, shuffle, stage, right? I want to see if there was something that had a input and output, but I don't see anything. But these are all the stages of how it's submitting work, okay, to your worker nodes. And that's where it's interesting because you can try to optimize stuff. And this tells you a DAG, which is a directed acyclic graph, okay? So scan CSV, shuffle the query stage, shuffle the query stage again, write code, shuffle the query stage. That's what it's doing. Still do not see anything. We can see this is running Scala because that's what the engine's written in. And the very last one, this is probably not even going to do any output, does our output. So I did not see anything of interest here, but we can see that that's how the Spark job runs. And it actually ran jobs 5 through 11 to just do something simple as reading it up. And what we can do is, if we were going to remove stuff, we could remove directories. We can do management directories by removing, like, for instance, Data Lake, RISSUG is the Redound SQL Server user group. Okay, we still meet. We talk about all data platforms. We just didn't rename ourselves. So we could either remove the directory and we could make directories if you want. I'm not going to do that right now. We can also list the directories. So for instance, if we run this, run cell, okay, we can see that I'm going to talk about pretty soon the taxi cab data from New York City. We also see we have a lending club and we have a power plant. So if we wanted to, we're going to have to remove the power plant and the lending club to actually write to it, right? So the problem I'm skipping over these sections is the data, the actual code. When you're talking about 2 billion rows, it actually takes some inertia to actually move that. And so that's why I'm getting rid of it. So this one, we see the power plant, that data set we brought in has 47,840 rows, right? To write it, again, it's very simple. Give it a path and then say data frame underscore plant, write what type I want. I want to write a Parquet file. I want to overwrite and I want to put in a destination path. Now, if I run this, okay, it's going to run. So one of the things I would be asking if we were interactive, not virtual, is, hey, I was in front of an audience, how many files do you think they're going to write out? And the answer is, it depends, okay? Why does it depend? Well, first and foremost, when you write this out, this ls of the right, it's going to give you some standard things like, hey, the Spark job was success, it was committed, it started, okay? Also, the number of files is depending upon the partitioning. Remember we talked about partitioning? So we see that there's snappy.parquet. Snappy is a compression format. Parquet is a parquet. So we see 2 files here. How did I get 2 files? Well, if we go back in the code up to here, we can say that I did a repartition too, right? Now, if we go ahead, I'm going to change this demo really quickly, and then we'll move on to next demo, but I'm going to read it in. But this time I'm going to split the data, which is really small, into 4 files, right? And now if I go back down to here and I do the write, so I'm going to run it, and I do this, we're going to suddenly see there's 4 data files, okay? So that's how partitioning works. Very easy. You can see just one little command, and guess what? Now suddenly we have 4 files. We're just randomly partitioning. We can also partition on a column, okay? So that's one way to take care of the data, is partitioning. Okay, so we talked about read-write files. Let's talk about processing. Okay. Weekly type files take more processing because you have to infer the schema, okay? I always suggest that you consider passing a DLL, data definition language string. So like, say I had 3 fields and there were doubles like we saw, so it would be V double, comma, you know, what was it, AT for temperature, double, comma, and whatever the fields are, continue. And then if you pass it in, it's not going to guess, it's going to take your word for the types, okay? Some files may have corrupt data, okay? And if so, you need to determine what to do. The default action is to just fail. Another way to do it is just to drop them, okay? And another way is to send them out to an error file. So we'll talk about the ways to handle corrupt data. Okay, so what we want to do, so far I talked about how to read and write, but we're not really doing that much interesting stuff, right? You want to do more than that. So how can we work with a database, say like a Hive database? So we want to talk about databases, tables, and views by Hive catalog. We also want to talk about Spark SQL, okay? This allows you to write dynamic Spark SQL off, okay, any of the tables in the catalog. So the catalog tables are just a mapping to the file location that says, hey, this is a table and this is the format, so it's the schema, right? And use the schema on read. We can also use %SQL for allow for static execution of commands. So we can say, hey, run this command. Most people will use Spark.SQL in brackets with a command and set it to a data frame because then we can do something with it. Once you get the data frame, say you ran a SQL, you can create another temporary view just for the session by using create or replace temporary view. For more details, refer to the documentation on Databricks. However, we're going to talk about the New York City cab data, okay? Again, I cut this demo down because, again, we have 15 minutes and I still have a bunch of sections go. So I'm going to talk about a lot of these, but I'm going to leave it up to you to finish off the execution, okay? So if we run all above, we can see that eventually it should show my header. I don't know why that there's a new interface and it's kind of a bug. Maybe it's just because I have too big of a thing, or maybe it just doesn't like Chrome, but there is a header here. So it just sometimes shows, sometimes it doesn't show. I don't know why. If we're interested, the README for the New York City cab is here, and we can just run sh to look at it, and it shows a bunch of directories. Right now, I have this data actually published, okay? So we can see that we have New York City, and that if we went into data, right, and again, if we hold the control key down, right, click data, right, and say if I do New York City, and let's see if we can do this, hopefully this works correctly, and then green cab, when you hold the control key down and you navigate and then click an action, it will spin it up in a new window, okay? So it's a little trick. Otherwise, it changes where you're working to where it's going. So now it's going to load this New York City green cab data, and hopefully it's going to show me some data. And it's going to take a little while because this one I think is only 1 million records or something like that, or 25 million. It's not that much, but the yellow cab is the biggest. It's 1.6 million, and I think the for hire vehicles is like 270 million rows. So there's a lot of data here. So you can see this is quite long, and it's not partitioned. And it also pulled up some sample data, okay? So that's how you use the Hive, okay? But I'm going to rebuild the Hive for you. So what we're going to do is we're going to run a command, okay? If we hit display, we can see, obviously, I set this to Spark SQL show database. As I show, brings a textual view. If we do display, okay, it actually goes ahead and shows a data set or data frame that we could do, again, quick analysis under. I'm going to cascade and delete them, and we're going to rebuild all this from scratch. So I'm just going to run the cell, okay? And now, if I go back to data, right, see this is all errored out, okay? And I can just go and just do, for instance, I could say, hey, you know what, while I'm talking on one, I can get the next one working, okay? So now we got rid of this, we want to create the data. We can see that under data, there's no New York City. So to create the container or the database, we just hit run cell, okay? And now if we go to data, we can see that New York City appears, but there's no data on it, okay? No tables. After some analysis of the data, I didn't notice that there was an issue with one of the data sets. It was the yellow taxi data set, okay? And this one's actually showing you what the taxi zone lookup is, okay? So let's talk about this. We could, run this code right here, and this does a couple things. First, it goes ahead and creates a directory under bronze, payment type, okay? And then what's going to do, it's going to copy over the payment type to first the bronze zone, and it's going to make a copy of it to the refined zone. Now, we could have just read this up and wrote it back, say, as instead of the CSV, we could have wrote it back as a Parquet file. I didn't, so I'm leaving everything CSV. I repeated this for the actual rate code and for this is the zone, right? So again, we could run the commands to list this files. We're not going to do that. Let's talk about creating the tables again, because the tables are interesting. You know, having data sitting out there is not interesting, but the ability to do something with the data is awesome, right? So we're going to drop the table if it exists, okay? And that's why I said try, and if so, if errors, then continue, right? That's my exist. There's no drop table if exists, or there might be, but I didn't use it. And then last but not least, create table. Specify database, table name. I'm telling it's a CSV file. I'm given the location in the silver zone, and I'm telling it has headers, right? And this triple quotes is saying here document and then run it. So if I run this, okay, this is going to bring the data in. I'm going to repeat this, and we can see that the data is there. We can do the same thing with the rate code. So run. And again, I'm going to speed it up a little because we're running a little behind. And we run this rate code, and we can see some data, right? And eventually it shows up, right? We can see 6 rows. Last not least, we can do the zone. Now the zone is a little bigger than the other two, right? And we can do some more complex stuff. So far I did select star from. We can do select star, order it by 2 columns, and limit to 10 records, okay? So this is more like MySQL syntax. So get top 10, like in SQL Server, this is MySQL, and we can see there's only 10 records, okay? Last but not least, we can do a select count. So we're using all those SQL skills that we did just by running this one piece of code right here, which we say, hey, drop a table and then create a table based upon a file. And now we can suddenly do all the SQL we did when we were doing SQL Server. Now we can create this table, okay, on the rate code. However, I'm going to skip this, okay? And we can ask, this is a real complex thing. We can format it to, we can see it's 1.6 billion rows. So that's why I'm going to skip it. We can also look at the CMT limit 50. One thing is we notice that that rate code is null, right? We know there's rates, right? If we go back to rates, right, way up here, these are the rate codes we should be using. But guess what? There's null. So that means there's a data integrity issue. Okay, how do we solve that? Okay. Well, to solve that, we have to reload the data. So we're going to copy over the whole directory of green taxi to green, and so on. We're going to copy over the CSV files from green taxi to, but this is what we're going to do, is that we might have some malformed data. So I'm taking care of that by saying drop malformed data. We're also saying it's comma delimited. This is a CSV that's zip file. It has a header. One other thing we also notice is that Hive might error when there's certain column names that are not good. So what we want to do is we want to take a column that has a space and rename it. Okay, so we're renaming it, and then we're saving it back as a Delta file. Okay, so I'm going to skip all that, and I'm going to show you that the reprocessed version of the files, which I ran for all three, green taxi and so on, will have this fixed. Okay, so we run this one, we can see that I just reloaded the table. So now I've made a Hive table that points to it, right? And now I can select, and it will run, boom. And then we can count the number of rows, and I'm gonna skip this one, but we can see it's 25 million, right, 0.7. We can also look at the yellow taxi. We can see these are all Parquet files now, right? Because I saved it as Delta. And now if we bring up the yellow, right, I'm gonna run this because I did get rid of the tables after we build the tables. And we take a look at the top 100. Okay, and hopefully this comes up. We can see that the top 100 now, if we go to rate code, see, we fixed the data integrity issue by reloading the data, okay, from valid data. And that happens in production. You know, someone gives you a bad file, you're gonna have to reload it, right? This is our 4 Hive vehicles. Okay, I'm gonna run this one. And last but not least, once that comes back, which is pretty quick, you can see the Delta format comes really fast versus CSVs. And then eventually this will come back. And this one's 260 million rows. And please take a look at this link for Spark functions, a ton of Spark functions, okay? So let's talk about working with data frames. So remember we talked way at the beginning, there's two ways, Spark SQL and data frames. So we went over Spark SQL. Let's talk over data frames. So the main thing is there's a lot of functions. Can't refer to all of them today. df select is used to reduce the number of columns. With column is called to either reformat or create new columns, and where is to also is like filter. Okay, and that allows you to, so this reduces columns, this reduces rows. Okay, so let's look at the lending club data. Okay, because I got some really interesting complex transformations going there, and this will show you what we can do. So if we did an LS, we can see that there's a single CSV file and there's a text file. And if you're curious, you can cat the text file and find all about it. We can make some directories, right? And what we can do is we can copy over the data. Okay, I'm not going to do that, but we'd copy it over. It's right sitting there. Again, we can do ls, we can remove. There's a lot of functions you can do from the system command line. Okay. Now what we're going to do this time is we're going to read the raw file in. Okay. Then I'm going to use this raw file again. So I want to create something called loans. The very first statement is I'm going to reduce the number of fields. So I'm going to give it these fields. So now if I run this, okay, this is going to create a, maybe I had to run this. Maybe the files are not there. Let's go back. Skip the step. This one. Let's run this one. Try this again. And again, this is interactive. When you write a job, you want to make sure the rates are right. Now we can see some interesting things. Interest rate, well, it's a character. We want not that, right? Same thing with the utility. There's going to be a bunch of formatting we want to do and fixed, right? So let's talk about transformations. We can see there's 130,000 rows. So I copied this from some code that was out there. I think it might have been Databricks or Kaggle. I didn't put the reference here because I modified it. But basically, we want to do some transformations. For instance, we want to say, is it a bad loan? So we're going to create a new column, bad loan. When you're using functions, you have to import them from PySpark SQL functions. We do that. And we're going to say, is the loan in current or fully paid? Well, that means that's a good loan. But if we do the tilde, it means not, it's a bad loan. And then we cast it to a string, right? So that's what we're going to get there. These we're going to do a regex replace, and we cast a floats. This one we're going to do a couple substrings. We're going to get the earliest year, issue year. We're going to calculate the credit and lengths. And then we do a bunch of things for employees. First, we're going to get rid of all these bad characters. If it's less than 1 as a mnemonic, we put 0. If it's greater than 10, and we had to escape the plus sign, then it's 10. Otherwise, we get the number, we display it, and guess what? We can repartition it. So we're going to run this. Run cell. So we can see this has quite a lot of fields here, right? And did I run cell? Because it looks like it didn't, but maybe it did. I'm gonna run this again. Run cell. There we go. So we can see that we've, did some cleanup. We also, there should be some columns at the end, like the bad loan. I saw it somewhere. Bad loans here. Issue year, earliest year, credit length and years. So that's the thing, right? And what we can do is we can drop table, and this one, when we did this, we wrote a file out, right? So I can repetition. So far I showed you how to do CSV. Now we can repetition using Parquet. And I also showed you Delta, right? I think the first one was Delta. This is Parquet, next one. And so we can also refresh this, right? So if we had to relink this Parquet file, so we update the file, we might have to refresh it. And we can take a look at this, and we can see that we have 130,000 rows. But we can do exactly the same logic as before, but using data frames, Spark SQL. So we had this data frame raw. I'm just going to say, hey, I'm going to create this temporary view that's only valid to the section. It's not going to be posted into Hive. So I'm going to do that first. So I'm going to run to this one. Then I can, select star, and we can see we have the similar issue, right? Now we can do a SQL statement. We can say, hey, remember we had a bunch of fields we wanted to do the select. We can do the selects. We can also say when the case status is current, then is it a bad loan? False. If it's fully paid, then it's false. Others true. We can also do the regex we talked about in a cast. Also, we can do the substrings, right? And we can also figure out the age. So we did everything here we did before. We're going to repartition it and write it out as a second Parquet file, okay? So once we've run this, we've showed you how to now to do two complex, okay, pieces of SQL, okay? I thought I got rid of this. Why is it saying that it exists? Let me make sure. Did I not remove it? Need to run this one. Oops, I did not want to do that. If we run this one, we should be able to run it again. So that removes the file that's saying we can't overwrite it. I didn't put the overwrite option on. I should just put with overwrite mode, and then I wouldn't get that failure. And again, when doing this, make sure you use the right options. You'll find through testing, do you positive, negative? If it's no file, write it. If it's a file, how does it handle it? Does it work the way you want? Okay. And so now we did the same actions to take a source file, modify it, and create an output file. We're done. And what we did is we wrote it back out, and then I'm just going to post this as a second Hive table. And now we can see that we have the same data, okay? And you can compare it on your own. So the very last one is we're going to get into some complex SQL, okay? Exploring the lended club data, okay? And I'm going to get to the documentation here and talk about it. So exploring a data set with SQL. This section presentation is designed to reinforce the fact that SQL skills that you've learned all your life are now applicable to PySpark. Once you know how to read it up and save it as a data frame, or read it up as a data frame and save it to a temporary view, you can use all the Spark SQL that you have, which is similar to T-SQL, and be able to be functional, okay? I'm going to do the summary really quickly, and then we'll do the last example. So I've been doing the modern data platform design for Microsoft for a long time, okay? It basically allows this company to put a variety of data in a data lake. Some of the things we didn't talk about is, hey, you know, video, maybe pictures we want to do, so we can do like machine learning. That's really cool stuff, right? So the source data, it's basically a spoke and hub designs, right? And I didn't go over this, but in the middle of the hub, okay, is the data lake. The spokes, you got source data, which are the producers on one side, and they push the data into the lake, right? Or you can pull the data from the source into the lake. Then you can do processing in the different zones, right? And the file and curation is as consumers, right? And the consumer would be, guess what? Pulling from the data lake, right? The main thing to remember is that when you do this, naming standards are very, very important, okay? So it's the most important part of deploying objects, creating data entry, lake entries, coding, okay, is naming standards. Also make sure you do those code reviews, okay? Both Azure Databricks and Azure Synapse support the Apache Spark architecture. The skills that you learn with Python Spark can be transferable between the products, and the future is bright for those who can adapt, okay? There's some references here. This Databricks documentation. This is Spark SQL functions. It's from Apache. Spark data frames is from Apache. Again, Synapse is based on Apache. So again, once you go to Apache references, applicable both. Maybe a little twist here and there. Here's my article on the local file system. I'm going to wrap up the very last one, okay? So we can show, okay, if we run this, the tables in New York City. And we can see, remember if we had a temporary table, like a view of something, maybe it would show up here. We don't see it here, okay? So what we can do is we can go ahead and we can just look at 10 records. Sure, that's nothing that interesting, right? But let's look at maybe the Northeast states. We want to look at good versus bad loans and the average loan amount, okay? So we want to do something. So how can we do that? Well, we can select the address of the state, right? We can do bad loan, that's an indicator. We want the count of bad loans. We want the average of bad loans. We round around it, right? We're going to do grouping. We're going to have where the count of loans greater than 0, order by, and we're going to say state. And if we run this, we get a nice little data frame here, right? And if we click this, hopefully it ran it for me, we see the data. And then if we click a bar chart, and again, of course, it didn't want to do the one I had set up, but if we go back to line, and how did I have that? We have to go to plot options, and of course, I think I did address state. I don't want to put loan amount here, and I want to put this here, right? I think I also did grouping as loan year, loan amount, cancel. They should have also brought in, oh, I'm in the wrong one. That's why it's not showing. So it's this one. So if we click here, there we go. And then what we want to do is we just want to do a line chart. And there we go. So we can see now that if we look at all the staged, right, we can see that on average, right, the good loan amounts, say for Maine, are 14,000. But if you had anything over, say, like more to 20, that's where we had some bad loans, right? So we can see the average loan that was defaulted versus the average loan that was paid off, okay? Another way to do this is we want to maybe do a rolling average, right? We want to know for a given address state when, you know, tell me how much amount is so we can have a cumulative total going on, right? So I'm going to say if the earliest year, because unfortunately they did years and just numbers, right, is greater than less than 50, then what we're going to do is we're going to add 2,000 to it. So between anything that's 0 and 50, we consider it 2,000 to 2,050. Otherwise, we're going to put 1,900. So this is going to give us, you know, some numbers. And again, this doesn't really matter. I don't know why I was playing with this, but we can just bring it to data like this and we're all set. So we can see now we have loan year and amount. Okay, but we want to do a cumulative total. How can we do that? Well, we can use the CTE, right? So in the CTE we can go ahead and do is we can do the same transition I did right here, right? Which is a piece of code that said, hey, convert the loans, give me address date and loan amount. But then we're going to use that within the CTE to do a row number over. So we want to automatically give a row number over. And we want to petition by state, order by loan year, okay? And we want to do unbound proceeding to current row. And we also want to do the sum, right? And now if we do this, we can actually see that we've rank ordered all the loans for a given year, so state and year. So Connecticut, 2011, 3,500. So 3,500 plus 8,000 is 1,150. 1,150 plus 6,300, 1,780, okay? So we've just solved this very advanced problem using Spark SQL. Again, once you get it into a data frame and it's published into Hive, then you can do anything that your T-SQL skills allow you to do, okay? With that said, that's the end of the presentation. I'm going to open up the floor. I'm going to turn my mic back on and open up the floor for any questions.
By the way, great presentation,
Thank you.
Miner. Let me give everyone access to unmute themselves. Give me a second.
No problem.
I learned so much just for your information.
And it's going to take a little practice. So spend a couple of weeks and then you'll be a star.
Everyone, you do have access now to unmute yourself. If you have any questions, feel free to go ahead and ask.
You don't have to be shy, so speak up if you want. Okay, if everyone's dropping, that's fine. Please look at the GitHub repo. So John Miner 3 at GitHub. All the data is in there. That includes the notebooks. The only thing you have to do is go spin out a Databricks service. You can do that by just going to Azure and do new and then Databricks and follow the prompts to deploy it. And you can go ahead and get $200, I think, from Microsoft Free to go ahead and stop playing as long as you put a credit card down.
Sohail, can you please unmute yourself and ask the question?
Looks like he's unmuted.
He does have access to unmute himself.
Yeah.
All of you do have access to unmute yourself.
Hey, Ty, you can say hi. I see you there. So did you learn anything, Ty?
There is a latency in me as well. Give them a couple seconds. Go ahead and ask the question, guys. You do have access to unmute yourself.
I'll jump in here,
type it.
John. This was early when you were showing us the creation of the resources and such in Azure. Does the Databricks resource, can it be created through ARM templates?
Yes, it can be. In fact, one of the things I haven't had a chance to do is put a sample ARM template that I've used in the past to deploy it. I still am sharing my screen, so let's go back to it, and I want to show you something. So if you go back to this recent, the dashboard, right? I broke it into 2 resource groups. If you don't do this, it'll go all into the same resource group. And the reason why I don't like that is because if I spin up a lot of nodes, okay, that it's going to show up here, right? So remember the base node we had was 1 worker node and I meant 1 driver node and 2 worker nodes. So if we click on this in order and go to the bottom, we can see right now there's the VNet, right? But then we have 1 driver node. I don't know which one it is because they don't tell you. And then there's the 2 worker nodes. Also, remember I told you there's internal storage that you can't get access to? That's this storage right here. And if I went into it, it's going to say it's an access violation. So they lock it out. So you can't physically touch it. You have to use your utilities. One things I didn't show you, and again, read the article that I gave you, is that if you go to home, where is it? Go back this way. There's a thing called Import Explorer. You can upload files too. It will automatically go to file store.default, tables, right? But you can also move around on this mount point, right? So we can see if you mounted some storage roots there. Remember I created this SSIS directory, we can actually browse into it too. It doesn't really allow you to delete anything, like if I click on here, I can't right click, but it just gives you a preview of what's out there.
Thanks.
You're welcome. Any other questions? One last thing, I'm going to grab a book. I'll show you what the book is. If you really want to learn more, get this book. I'm still reading it. I just haven't had time, been busy working. So Bill Chambers and Mattia Zaraya did a Spark the Definitive Guide. And so I'm going to turn off this blurring. Apply background defects. You can see my basement. That's where I am today. But it's probably backwards. But this is Spark the Definitive Guide. You can get it on Amazon.com. It's a really good review. Also, Databricks has free training. You can just sign up for it and learn a lot of stuff that I showed you. I'm continuously learning, and there's always time to learn more. Is there any more questions? I saw in a hand. Sunil, you had a question? No more questions. I'm gonna go once. Sunil, you're unmuted, so if you want to talk, go for it. Going twice. Okay, Gene, we'll definitely call it a day. Thanks again for having me. And talk to you soon.
Thank you, John Miner, for your amazing presentation. I learned so much from it.
I'll see you.
And thank you all for participating with us. I would highly suggest you to go and register for Haitian SQL Saturday. And then thank you in advance, John Miner, for your presentation to our Haitian community.
I will see you at 4 p.m. on Saturday. That's when I'm presenting it. So if you want to see this again, hopefully I'll give it a little twist, but I'll see you then. Thank you and have an awesome week. Stay safe.
Thank you all.
Thank you, John.
You're
Thanks,
welcome.
Jeff.
Thank
Bye.
you all. Bye.
guys.